So, hi, Dave Rossum here at Superbooth for our Meet the Maker series. It's an honour. We've been trying to hook up since you kind of started showing up doing the Rossum electronics and the new modules, because your career in the industry is, it spanned a lot of time. And
yeah, it's coming up on 50 years next year.
Really?
Yep.
You don't look like that's possible. It keeps you healthy, right?
It certainly does. Well, I mean, I just get so much fun out of doing this stuff. My wife asked me when you're going to retire, and I said the problem with retiring is I'd just be doing the same thing. I wouldn't get paid for it. So she laughed. She puts up with me. I work a lot, but I love what I do.
It's interesting that because we all go through phases of falling in and out of love with when you have a passion that is maybe an interest that becomes work.
Mm-hmm.
The difficulty is sometimes you could kind of sour it occasionally.
Yeah.
How do you maintain your enthusiasm?
Well, some of it is coming to shows like this. I mean, it just delights me when I go to show. We're showing this new module Linnaeus at the show, which is a state variable filter with the crazy idea of sweeping the frequency into negative frequency with linear frequency modulation. And I listened to it, I liked it, but I never really know if it's musical until I see that, suddenly the big grin on a musician's face when he hears this thing, and I know he's hearing it in his mind and his music, and that's what I love. Because, unlike a lot of the synth manufacturers, I'm not a musician. I don't play at all. I've got genetic musical talent, but because of my sort of bizarre family history, I never learned to play any instruments. And but yet it's in my blood, and my dad was very much a scientist, so the engineering is in my blood. So my participation in music is by giving musicians the tools then seeing what they do.
You're very much from an engineering background. That's where you kind of started out. Is that the...
Yeah. Well, science and engineering. My actual university degree is in molecular biology.
Wow. Okay.
Now, it isn't quite as bizarre as it sounded, because my idea back in when I graduated from university in 1970 was to apply computers to the biological sciences. Back then, that was a crazy idea.
So is that like almost the advance of neural network?
Neural networks were part of that. I wanted to use computers to model the biological macromolecules, which is being done now. But this was, as I say, 50 years ago 50 years ago next year when I graduated. They're finally doing what I had envisioned.
I told you it was a good idea. You should have listened to me, right? So how did you get involved in the music world? Was it a question of like people around you said, "Hey, electronics? Can you fix this for me?" Or
the story has been told many times, but I was walked into the biology lab at UC Santa Cruz, and my thesis advisor, had left me a note saying, "I'm over in College 5 unpacking their brand new Moog synthesizer. Come on over if you want." And by the end of that day, I was teaching the music students how you use the synthesizer. That day changed my life.
what was it about that? I mean, because Bob used to talk a lot about the fact that there was a kind of spiritual connection to circuitry and stuff, which some people find a bit alien and weird. I mean, in your science background, I mean, is that what happened to you effectively when you were first exposed to an early electronic musical instrument?
All I can say is just something clicked, and I'm sure it had to do with this, like I say, genetic. Musical talent that runs in my family that I never developed because my dad was told as a child, he was raised by a single mom, and when he asked why he didn't have a dad in the household, he was told it was because his father was a musician and a drunk. And so Dad always associated music with an absent father. Okay. And I was very much my father's child. I was a scientist. I looked up to Dad. So because Dad didn't like music, it wasn't okay for me to like music, even though my brother was very musically talented and plays a number of instruments. And
it's funny how that kind of thing could just go through, and it's just literally, just that small chance that the way the stars align that way.
Yeah, wow. Yeah, but it turned me in the right direction for a wonderful career. So.
Okay, so we fast forward a little bit, and then now was the EMU systems, the kind of modular stuff, that's you kind of gravitated towards that happened because of your initial interest in...
Yeah, in that fall of 1970 when I was introduced to the Moog synthesizer, at university, I just dropped everything I was doing. I pretty much gave up on getting my PhD in biology and started really learning electronics. I'd had a little bit at Caltech, but I could pick it up pretty quickly. I had all the basis and the math and things like that to do it. And in December of 1970, with some friends at Caltech, we started to build a synthesizer, and the electronics company we were buying the parts from kept asking what our company name was, and so I made up the name Emu Systems. That was born in December 1970.
Again, I mean, it's kind of so much on the fly, and that ad hoc nature of things is great. I mean, it's nice to hear things that just sort of organically happen. I mean, in our minds, that's how we want things to do, but that's the way it worked for you, so that's fantastic. But the other thing that's really fascinating, I mean, you were kind of one of the first guys really to see the potential of the new emerging digital technology.
Yeah.
So, I mean, that must have been, because even now, people are still seeing what that can do. Mm-hmm. So back then it must have been really tough. I know just getting parts must have been really tough. Yeah,
well, when we started out, the integrated circuit was becoming available in 1970s. Our first use of digital electronics was in the keyboard. We built... I invented the polyphonic keyboard back in 1972-73 time frame, and then all of EMU's keyboards after that had digital electronics. When the microprocessor came out, it was actually the Z80 microprocessor. We were the first company to use a microprocessor in music with our 16-voice polyphonic keyboard and sequencer. So I was very familiar with computers, but they were far too slow to do any audio processing back then, but it was very clear that was going to happen. And I remember experimenting in 77, 78 with some very primitive signal processors that came out, one from Intel, one from TI. And you could do some audio, but nothing that was really musical, in my opinion, with it. And then we had this arrangement with sequential that went sour, and all of a sudden we needed a product. And that was right when doing the simple processing you could do in the emulator became practical, and that was the big turn in direction for EMU.
Even then, that must have been really pushing what was viable with digital technology. Because I mean, the sample rates were lower and the bit depth was lower, but it's still pretty fast in terms of megahertz. I mean,
and in the emulator, I came up with this idea that I thought was going to work just fine, and it turned out the chips weren't quite fast enough, and so I had to do a quick respin with putting a bunch of FIFOs into the emulator 1 to be able to get that very simple signal processing to happen fast enough that we could do eight voices all at once.
So did you kind of find yourself being the digital guy during that? Were you the guy that kind of got that, or was it a kind of team effort in terms of you were still doing the analog electrodes? Because I've heard you say you now just really like working with analog again because it's more, I guess, more direct. And it's less IT, I suppose.
Yeah. Back then, I very much became the digital inventor. And in fact, all along, I was really the engineer at EMU until really the mid '80s, I built hand built the development system. Actually, the Prophet 5 was developed on a computer that I hand assembled from chips.
Wow.
And Dave Smith came over to EMU, and we were working together and used that computer to do all of the software. But Dave did the software, and Dave did all the digital design for the Prophet 5. But he came to us and said, I can do analog, but I'm not very good at it. Dave, would you do the analog design for the Prophet Rev 5? So it was all my designs in the Rev 1 and Rev 2.
So it must have been really rewarding. I mean, because your instruments defined an entire generation of music technology, which enabled whole new swathes of music to happen. I mean, that must have been great. I mean,
when I remember the first day we actually recorded a violin on the emulator, on the prototype emulator. That was it must have been December of 1980. And we had a friend who could play the violin pretty well come over, and we'd just gotten the sampling up on it. And I went out for a break of some sort, had to run an errand, and I came back, and Ed Rudnick and Marco and this guy, Ken Provost, who was our friend who played the violin, I walked in the door, and they say, we really have something here. It's like that was the moment that we realized that sampling synthesis was going to be something. And then a decade, maybe a little more than that later, Mark and I were reflecting on it, and Marco says, we've changed the way the world makes music. And it was just, okay, yeah, and that was...
You got that moment where...
Yeah, exactly. When all of a sudden it's like, okay, yeah, 10 years ago, this was brand new. Nobody really done it in that way before, in that successful way. And now it is the way music is made. And still, sampling synthesis
but not
is
only that. I mean, you got the sampling, and then you also got the kind of the digital drum machine. Which,
right, yeah.
Again, that you and Roger and kind of really... That really changed everything.
Yeah. I mean, Roger really needs the credit for that insight. He was the guy who came up with the LM1. I had the privilege of doing the design review on the LM1 for Roger, and then we came up with the drumulator. But perhaps the instrument that I love most in my life is the SP12 and the SP1200 because they brought out hip hop. And I love the concept of hip hop. I listen to hip hop music, and it inspires me in a way that no other music does because
it's
so
visceral,
different.
isn't it?
It's visceral, and the poetry in it. It's poetry about a world that's largely foreign. White middle class kid. I've never lived those experiences, but to hear them in the poetry, it's like I can relate to this, and I love the fact that it's out there and does that to me. There's no other music that really gives me that kind of experience. And then I've met some of the hip hop musicians, and they are so grateful to me for this instrument, and that's just really cool. That like I said, the thrill for me is when somebody can take something I've designed and really turn it into something that creates art. How magical.
Awesome. Yeah, no, God, yeah, I can imagine that must be just great. Just going back to the kind of early digital stuff. I mean, I guess also there must have been very little tools like programming tools and things. Did you have to design your own environments to kind of write this code?
Yeah. I mean, it even goes further than that. I'll tell you that in a second. But we built the development system for the Z80. Built up this whole thing ourselves because you could buy development systems then, but they cost much more than a little company like EMU could afford. And wrote our own operating systems. The operating system for the emulator was a true full-blown real-time operating system. I wrote from the ground up. I was the programmer back then too. Did you have any input on the Mirage as well? No, I didn't. We knew the Ensoniq guys were doing this, but I didn't really get to know them until really much later. I became fairly good friends with them when Creative acquired Ensoniq, and I got to hang out with them. And
cool.
Again, then you find all your common connections and things like that. That was really a kick.
So the tools that you were building, I mean, you built the development systems, you built the kind of, and then the coding environments. Because again, I remember back in the day there were people who, there was like Borland. You would buy a box set and you would have access to this kind of code. But that's even a level up from what were you doing, like machine code stuff?
Yeah, we were doing assembly language. All the emulator and emulator 2 and SP12 and SP1200 were all written in Z80 assembly language.
That's so abstract.
Yeah, and. We had pretty good techniques back then. We got one of the very early chip-based Unix development systems early on, and one of the first engineers I hired got me hooked on that, taught me all about that, and but. What I was going to say is even when we started developing chips, things like our, the E-chip, which was the chip in the Emacs, was the first digital chip I really did, and then the G&H chip, which powered so many generations of EMU products. Those all of those, we had to develop our own development methodology for developing DSP chips at the time because there really weren't any of the environments that are just plentiful today in the standard way of doing it. But to be able to go from listening to an audio algorithm that we simulated in non-real time but could play back the sound in real time to prove that yes, the algorithm really sounded good, all the way down to the individual ones and zeros on the chip and make sure the chip was exactly right.
Yeah,
and we did it. It's like I don't think any of my chips didn't work the first time.
Well, that's awesome. I mean, that's a testament to your kind of understanding of the environment you're working in. I mean, do you kind of I think the thing about coding, especially at an abstract level, you have to hold so much of it in your head. I mean,
Yeah.
and I program on a very basic level, but when I'm thinking about a big project, I find it very hard to participate in real life because I'm constantly there's stuff kind of going back in your mind. Quite often you think I've got a solution, it just comes to you.
Yeah, yeah. I get them in my sleep frequently. I'll wake up from a dream and suddenly I'll have the answer to things. I love it when that happens, and that's frequently the inspirations too. I mean, these twists. I mean, like the through zero filter that it's sitting in front of us all. Why didn't anybody do it before? And it turned out somebody had done it with a phaser filter, but not with a state variable filter. And the state variable filter sounds so much better. And that just it comes in a lightning bolt. I was talking to my friend Gary Hull in the lab, and he was encouraging me to try and recreate the analog state variable filter that was in the EMU modular. I told him I wanted to do something new, and just at that moment, linear and then linear through zero. And I said, oh my God, Gary, I've got this great idea. And
so now, I mean, are you kind of focusing more on the analog design and that side of it? Is that what gives you more pleasure, like right now?
I love analog design. Only two of Rossum Electro's modules are analog modules at this point. That's the Trident oscillator and the Evolution filter. The rest of them are digital because the digital technology is so much more powerful than the analog. You can do so much more, so much more quickly, and give the musician a better tool. But I love the analog design. I've juggled so many balls, it's unbelievable. One of them, I'm a technical fellow at Universal Audio. And I call myself their tame analog designer because I work in the algorithm group where they're digitally recreating these classical circuits. And the engineers there will come to me and say, Dave, this schematic doesn't make any sense. I go, well, back in those days, we used to think this, and explain to them how the schematic works. And that's just part of my job there. I do other analog design for them. And that again, is really fun for me, and it's a great synergy. They have so many brilliant programmers in digital design. And I just love being around the smart people.
So, these days, what's your role? Are you actually hands-on, or are you more kind of conceptual, or where do you kind of fit now? I mean, I have a sneaking suspicion you still sit there and you type out code.
Yep. Yeah, absolutely. So I in Rossum Electro, I am the primary. Well, I'm the hardware engineer, and I do some of the low-level coding. I've got Bob Bliss, who was the author of the EOS operating system for EMU, a long-time EMU employee. I've known Bob since 1985, I guess. And so I stole him away from Creative, and so he was the other engineer at Rossum Electro. So the two of us have done all of the thing. Bob does all the high-level coding, and really he's the power behind the new panharmonium module as well. That was his concept. I've had only marginal involvement with that other than designing the hardware for him.
And so, we were talking a little bit before I started rolling that, you've been very much in the past sort of behind the scenes guy. Now you're getting a lot of recognition for kind of being the originator of a lot of the core concepts and core ideas that are being used today.
Yeah.
And how are you finding that now, being out in the public and just sort of being like, hey, that's Dave Rossum who did the, that must be kind of great.
Yeah, it's very satisfying. It does stroke your ego to, walk through Superbooth. Hey, there's Dave Rossum, right? Have somebody come up and a few people have literally come up to me at the booth and gone down on their knees and bowed. It's silly and we laugh about it, but it is, it certainly strokes your ego to get that. But, it also gives me a chance to tell the stories and tell them correctly. And when I first started Rossum Electro, Amazona had an interview series with me. And when they sent me the questions, they were sort of questions that remind you of, when did you stop beating your wife type of question. Because they all just assumed that when Creative acquired EMU, EMU went in the toilet because of that, and nothing could be further from the truth than that. That Creative was very supportive of EMU for so many years, and so I was able to tell that story and straighten people out on that. And that really, it was a service to people, it was a service to Creative, and it needed to be done. So in that sense, being able to tell the stories and what it was like back then, and
there are so many myths, aren't there?
Right, yeah, and the other thing is being able to share those experiences with the young folks of today that are coming in and becoming designers, and you can hopefully steer them on their path so they can be more successful, so they don't have to make the same mistakes that I did.
Well, here's a question. I mean, do you think that there's a pipeline of new engineers and designers and coders who have the same sort of depth of knowledge and are able to kind of think, in that kind of non-linear mode and come up with new concepts? Or is that level of education, that level of knowledge, just sort of not catered for in the current sort of climate?
There's a spectrum there, and I think the really creative people and who are going to come up with truly novel ideas are just a very small part of the bell curve. There are, and I think it's fine. I don't in any way want to discourage anybody from going onto the internet, finding a circuit and copying it and making a circuit board themselves. That's how you learn this stuff. I mean,
sure.
I first learned about musical instruments by taking the schematics that came with the Moog Model 12 at UC Santa Cruz and studying those until I could tell you what every part did in Bob Moog's designs. I had the wonderful experience of having Bob Moog there, and when I finally got to know him, he was totally delighted that I'd had the same inspiration he had, and didn't in any way feel ripped off that I'd started by following his schematics. He thought that was wonderful and was very encouraging.
Well, I guess it's kind of like science, isn't it? It's like some of these concepts they're almost sort of plucked out of thin air, because they take a kind of the concept of nothingness, and
right.
Like you were saying, you woke up and you had an idea that
right.
just came from nothing.
Right. I mean, the one thing that I will say disappoints me in some of the world of Superbooth is that people lift the ideas and don't realize that it's very important to admit where you got it from and honor what you're deriving from. And one of the things that does upset me, there's some people that are copying Doug Curtis's chips, and they don't come out and say, hey, this was designed by this brilliant guy Doug Curtis, we just copied the masks. It's legal to copy the masks, but I just think it's just not very pleasant to not honor this brilliant man that I knew and respected deeply.
Yeah, I get there's this sort of courtesy and a moral code, I think.
Yeah.
And I think the difficulty becomes because business is so cutthroat, and when you're dealing with kind of cross international border kind of, all the shavings and the way that you've got to make your costs. I mean, people become very ruthless, I think, without necessarily doing it for that reason. It's just like that's what you do.
Yeah, I think there's the ruthless side of it, but there's also the just ignorant side of it that I love, and it's one of the reasons I got into the Eurorack world is because there is a share and share alike attitude. And I have any number of people who have come to me and said, hey Dave, how did this circuit work, or would you review my design? I'm happy to share my knowledge that way within this community. It's wonderful. But the flip side of that is that as a community we should support one another by acknowledging each other as well. And so I think there's some people that just don't understand that doesn't, over my career I've learned the more you thank other people and attribute to things, the more respect you get. The more I say, hey, it really isn't mine, the more people think, oh, it really is.
Good tactic. Yeah, what a great way to close. That's great advice, actually. So what's next? I mean, you must have a whole string of things that you want to get on the bench and start making, right?
Yeah. I mean, at this point, I don't have any hot idea that I've got to do. I've got a lot of projects that I'd love to do. I've got some plans for the next year that hopefully when I'm here next year I'll have one of the ones that I'm thinking of right now, but I really can't say anything about.
I understand.
Will come to fruition, but we'll just have to see how that plays out. But Rossum Electro looks like we're going to have a successful year with our 3 new products, and may be able to grow a little bit this year, I'd love to make the company a little larger, and as a result, be able to do more things more quickly for the musicians, because that's what it's all about. But the truth is that I'm just having the time of my life doing this, and I love being at Superbooth. It's a great show, and has just such good energy about it. I've had very little sleep, but a real blast for these past few days.
I can relate. Dave Rossum, thank you so much for talking to us.
Oh, you're very welcome.